question 11. So let's start off by just rewriting this part here, just to make it a little bit more useful, using index notation. So that's to the power of 4, sorry, to the power of a half, 4 to the power of a half, and then we've got minus a half there. Right, okay, so let's now just try and think about what each part of this actually is. Now remember, we only really need to work out the first 3 terms here. So let's just do this bit here first of all. What's that going to give us? Well, let's just pretend we can do half C0, okay? Remember, in maths we do a lot of cheating, and this is how I prefer to set these out. Don't actually work anything out for a minute. So I'm just doing just standard bit of binomial expansion, and I'll worry about the problems in a minute, and then we'll sort them out. 1, 1, here we go. Now this decreases by 1, there we go, and then this number increases by 1. There we are. Right, now let's work out anything that we can actually do without too much bother. So for instance, 1 to the power of a half, I can do that, I don't need to think about that. Number to the power of 0, I don't need to think about that, that's 1. I'm going to have a 4x there, I can have a 1, another 1, I can have 16x squared. So these are our problems over here. I'm going to start with this one just here. Okay, this is the one that I'll explain to you. So half C1. All right. Now NCR is n factorial over n minus r factorial. So let's make sense. If I've got a half, so that would give me a half factorial. Now clearly, if you go and put half factorial into your calculator, your calculator will complain about it because you can't really do it. But we often cheat in maths. So when r is 1, that would mean minus a half factorial and 1 factorial. Okay, what's going on here? What's this bit here? So a half factorial in theory means a half multiplied by minus a half multiplied by minus 3 over 2, and just carry on going forever. Minus a half factorial is minus a half times minus 3 over 2, etc. Carry on for together. So if you do this divided by this, it's just half divided by 1. There you go. Half. If you do it to this one, that's a bit easier. You can try that. 1. If you do exactly the same idea, you can have a little go. On this one here, you get minus 1/8. Okay, you have a go. You try that bit. Right. Now we need to do this part. Oh, I just need to write down what the answer is to this, don't we? We've got 1 plus, that gives us 1 plus 2x minus 2x squared. And then obviously there's going to be some more there, right? We're not interested in the rest of it. So let's just go over and let's sort out just this part just here. 1 minus x minus half. Right, so if I do this in exactly the same way, so I've got minus a half C0. Yes, of course, it doesn't make sense. Minus a half C1, minus a half C2. Okay, put all these in. So we've got 1 minus a half, 1 minus 3 over 2, 1 minus 5 over 2. And then what have we got? We've got negative x to the 0, negative x to the 1, negative x squared. Now, if I go and do all of these individually, okay, put it together, and that's going to give me overall, it will give me 1 plus half x plus 3 over 8 x squared. So that's the answer to that bit. Remember, there'll obviously be a bit more, all right? When you're expanding, when you're doing a binomial expansion, it generally only, if you've got a fraction, generally only do about three or four terms, 4 at the very most. Right, okay, so now we need to imagine these two things multiplied together. So let's just piece that together. What have we got? We've got 1 plus 2x minus 2x squared. Okay, we know there's a bit more there, and then we're going to multiply that by the other term, which is 38x squared. Right, let's just multiply it out and see where we get to. So 1 times 1, 1. 1 times, so we've got half x. 1 times this one, plus 3 over 8x. Right, 1's finished its job. 2x times 1, plus 2x. 2x times half x. So that'll be plus x squared. Now this one times this one I don't need to do because it's going to give me x cubed. I only need the first 3 parts, so I'm going to ignore that. So minus 2x squared. And likewise, I don't need to go any further just there. So now if we piece this part together, what do we end up with? We end up with 1 and plus 5 over 2x, and then the x squared. What do we got? We've got minus 5 over 8x squared, which is, hurrah, that's what we actually wanted at the beginning. That was a question, right? It was just trying to show that there. Right, okay, fantastic. Now part B. Part B says give a reason why a student should not use x equals a half in an attempt to find out this square root of 6. And if you look at this part of the expansion, 1 plus 4x to the half, it is only valid, you need to look at when these are valid, it's only valid when modulus of x is less than a quarter. So you might need to look at that. All right, there you go. Right, part C. Now part C tells us to sub in x equals 1 over 11. Okay, so, and then we're going to try to say to obtain an approximation to root 6. So let's just start off. Let's just put 1 over 11 into this, what we just worked out. So let's go back down here and let's just sub in 1 over 11 into here. So if you pop 1 over 11 into this here, we end up getting 1183, just use your calculator there, 968. Right, how's that going to help us? Well, if you go now and we look to think about putting 1 over 11 into here, just have a look to see what that actually looks like, what you've just worked out. All right, so if we put 1 over 11 into there, you get 1 plus 4 over 11 over 10 over 11, which equals, so we're actually trying to do a square root of 50. Oh, wait a minute, that's the square root of 1.5. Right, so we've just worked out what we've just done by subbing in x equals 1 over 11. We've just got an approximation for root 1.5. Now you should know, remember we want an approximation for root 6. But wait a minute, isn't root 6 the same as root 4 times 1.5? So the square root of 4 is 2. So root 6 will be 2 multiplied by root 1.5. Now we've just approximated root 1.5. So if we multiply this by 2, we get our answer. So an approximation for root 6 is 1183 over 484. Done.